From its launch in March of 2023, OpenAI GPT-4's pricing has dropped nearly 74% for output tokens and 83% for input tokens. And now that raises an interesting question. How do these models keep getting faster and cheaper and smaller while maintaining the same level of performance or even becoming smarter over time? How does that happen? The answer lies in a process called model distillation. It's one of many techniques used by OpenAI and other similar companies. And in this video, we'll break down exactly how that works. I'm Rohan from Ionio. Over the last 4 years, we have helped dozens and dozens of companies of all sizes, bootstrapped, funded, public, build and launch AI and SaaS products. And in this video, we'll just go over model distillation. Let's jump right into it. Model distillation is based on a paradigm called the student-teacher paradigm. In this setup, the larger, more powerful model acts like a teacher for the smaller, more efficient model. The teacher's job is not to just break down the answers, but also break down how it got there. Essentially sharing not just the answer, but also the reasoning to get that particular answer with the smaller model. The teacher solves a specific set of problems while explaining the entire thought process. Then the student model absorbs this information and tries to replicate the final solutions and the logic behind those solutions. And all of this at a drastically reduced size and cost. So instead of training the smaller model from scratch on the raw data, you train this model on the learnings and the thought patterns of the teacher. Here's a real world example. Imagine a use case where we have a 405 billion parameter Llama 3 model, which is used for mathematical reasoning or problem solving. In this case, while the Llama model even outperforms the GPT-4o model on the GSM 8K and math benchmarks, in most use cases, we might not even need all of this computation. So in this case, we can take the Llama 3.1 8 billion parameter model. While being 50 times smaller, it still achieves pretty impressive scores on the GSM 8K and ARC challenge benchmarks, which makes it more suitable for many practical applications, like summarizing, like rephrasing sentences, and other similar tasks. This model distillation student-teacher paradigm is huge because it allows us to train models which are much smaller, but those that can still outperform the larger models or the models at its same level. Now let's talk numbers. A large model like the Llama 405 billion parameter model might cost anywhere between $20,000 to $30,000 per month to run. But the Llama 70 billion parameter model might only cost around $5,000 per month to run. If you go smaller and you're able to train a student model which is 8 billion parameters, then you can run it for anywhere between $200 to $300 per month, depending on which hosting provider you choose. So in practice, you're able to reduce expenses by a factor of at least 75% if you pick the correct model size for the correct task. And as the models get smarter and smarter, we would not need these larger and larger models. And the role of these larger models then becomes more for training instead of being actually used for inference. So these become teachers more than they become workers. Another consequence of using smaller models are that they are significantly faster. So as we move in 2025, we will start to see more voice AI assistants. And as we move towards them, the model inference speed starts to become pretty important. And in those cases, smaller models, anything at around 8 billion parameter models would be really, really quick to respond while being smart enough to handle most conversation, as long as it is not strong reasoning-based tasks. So yeah, smaller models are faster. That's another advantage. Here is another way you could use model distillation, but you're not supposed to do this in enterprise, in production, especially if you're a large public-facing company. But here is what you could do. So if you have a proprietary model from an API provider that is performing well on a specific narrow task, and you want to replicate that performance in an open source model on your own LLM, then what you could do, and this would void the terms of use of these API providers, but you could use the larger model, the proprietary model, the smarter model, the more expensive model to generate synthetic data. And you could generate several thousand rows of synthetic data, and then you could feed these to a smaller model. And depending on your use case, in most cases, you would be around the 70 billion parameter model range. And you could just give this synthetic data to that smaller model, the student model, and have a cheaper model that has the performance of the larger proprietary model deployed on your own internal data centers. So yeah, that's pretty much it. That's model distillation, how you can use it, how it works, and how you're not supposed to use it. That's it. Thanks. I'll see you. Bye-bye.